calculus class, I keep solving exercise problems pre AP calculus course. It's not pre-calculus. It's kind of review of pre-calculus to prepare the next year AP calculus class. It's all about functions. Okay, let's just start from number 7. Which of the following equation has a graph that is symmetric with respect to the origin? It says a graph should be what? Symmetric respect to the origin. So what is symmetric with respect to origin? That means that the fx, that graph, the function is odd function. Odd function. All right, I said odd functions. Odd functions definition is f of negative x is equal to negative f of x. One more time, f of negative x is equal to negative f of x. Number 2, that all the function in the polynomial functions, if polynomial function has all odd powers, like y equals x to the 5th powers, minus 3x to the 3rd powers, plus 5x, x means first powers. Think about exponent, okay? 5, 3, 1. All exponents is odd numbers, right? And then you can say that is odd functions, okay? If you plug in negative x for x, that value should be, that equation exactly equal to negative f of x, right? That's why all odd powered function is odd function. In the trigonometry functions, y equals sine x and y equals tangent x, odd functions. Odd functions graph of the odd function is symmetric with respect to origin. So this sentence, symmetric with respect to the origin, exactly explain odd functions graphical meaning. Okay, the meaning of odd function graphically is symmetric with respect to origin. So the question basically asks you just to find what choice is odd function. So C is the answer because third power and then first power. So all odd powers, right? That's why C is the odd function. So C is the answer. Number 8. Let G be a function defined all reals which of the following conditions is not sufficient to guarantee G has an inverse function. Alright, if a function has an inverse function, if G has an inverse function, that means G should be one-to-one function. Only one-to-one function has inverse as of functions. So one-to-one function's inverse is a function as well. So we're going to use a vertical line test or horizontal line test, right? Vertical line test just is used to tell given function is function, given graph is function graph or not. Sometimes you can use a horizontal line test to know that function's inverse is a function or not. Okay, anyway, one-to-one, what a one-to-one functions graph looks like. One-to-one function graph should be strictly decreasing or strictly increasing. Strictly decreasing means there is no any part of the graph decreasing. Keep increasing like this. That is strictly increasing function graph, right? What about strictly decreasing? Is it keep decreasing? It's never increasing in any part of the graph. So strictly increasing and strictly decreasing, that kind of graph is what? One-to-one function graph. That kind of graph represents what? Has inverse as a function as well. So B says what? G is strictly decreasing. That is right. That is right. That is a guarantee. G has an inverse function. And then what about D? G is strictly increasing. That's right. That's right. And what about E? G is one-to-one function. I told you one-to-one, only one-to-one function has inverse function. So A, B, D, E is right. What about A? AX plus B, but A is not 0. That means linear equation. So it's increasing or keep decreasing because A is not 0. If A is 0, it's constant function that has no that has no inverse function. But if a is not zero, is keep increasing or keep decreasing, something like that. That means one-term function, right? So a is guarantee that G has an inverse function. But C doesn't guarantee it because symmetric to the origin, that is, what definition is that? This is a definition of order function. It is order function's definition. We just solved in number 7, right? Order function graph is symmetric to the origin, but that doesn't mean it has inverse function. That doesn't mean strictly increasing or decreasing. So answer is C. All right, number 9. Number 9 says let y equals fx is equal to sine of arctangent x. You need to understand what is the arctangent x means. Arctangent x actually represents the angle, right? Arcsine, arccosine, arctangent means angle, right? If sine pi over 2 is 1, arcsine, sine inverse of 1 is pi over 2. That's inverse functions x and y switched, right? Something like that. So inverse sine is the angle, right? So arctangent means angle, okay? The tangent is what? The value of tangent of that angle is x. That makes sense, right? That means what? Tangent theta is to x. I'm sorry, tangent x equals arctangent x. Suppose arctangent x of theta, and then tangent theta equals x. That makes sense, right? But tangent theta, that doesn't exist at pi equals 2. Tangent x graph is this. Tangent x graph, you remember this graph, right? Something like this. So at x equals pi over 2, or x equals 3 pi over 2, or 5 pi over 2, tangent x doesn't exist. That makes sense, right? So that fx is sine. Sine value is, sine x is basically between -1 and 1. But arctangent x cannot be pi over 2. Because arctangent x means angle, right? At pi over 2, tangent x doesn't exist. So arctangent x cannot be pi over 2, or cannot be 3 pi over 2. Got it? If arctangent x is pi over 2, sine of pi over 2, it is 1. It is 1. That means sine arctangent x cannot be 1, because arctangent x cannot be pi over 2. So 1 is not. So sine x is less than 1, but that is not equal to 1. Sine x cannot be 1 in this case. And then if angle the theta is 3 pi over 2, arctangent x doesn't exist. So arctangent x doesn't exist if that angle is 3 pi over 2. So if that arctangent x, that part 3 pi over 2, sine 3 pi over 2 is -1. So -1 should be excluded as well, not included. So range of the function fx, sine of arctangent x, that y value is between -1 and 1, exclusive. So B is the answer. B is the answer. Basically, sine is what? Between -1 and 1, inclusive. So C looks like answer, but because arctangent x doesn't exist at pi over 2 and 3 pi over 2, and then sine pi over 2 is 1, sine 3 pi over 2 is -1, so we have to accept those two numbers. Okay, let's go to number 10. Let g of x equals absolute value of cosine x minus 1. The absolute maximum value attained by g on closed interval 0 to 2 pi for x is equal to. Okay, find the x value to where the gx has a maximum value, right? to find the x value where the gx has maximum value. So I'm going to draw the function graph basically. How can I draw the cosine x graph? It is x-axis, it is y-axis. Cosine x starts from maximum point 1, 0, and then looks like this. And then the period is 2 pi, right? So 0 to 2 pi. And then maximum value is 1, minimum value is negative 1. So cosine is between 1 and negative 1. And then what about, it is y equals cosine x graph, right? So now try to draw cosine x minus 1. That means that graph translated vertically 1 unit down. Got it, right? So start from 0, 0, and then going down up to negative 2, and 2, 0, 0. Because 1 unit down, it is 0, this is negative 2. So the blue graph represents cosine x minus 1. But we have to find our graph should be absolute value of cosine x minus 1. So how can you find that absolute value of fx graph? You just flip over the x-axis. If every single part under the x-axis should be flipped over the x-axis, because absolute value make any number to become positive, right? So I'm gonna draw again here. That blue graph was started from 0 to negative 2, right? And then it is every single part, all graph is under the x-axis, right? So you have to flip over. So they're gonna be this kind of shapes. And then this is 0 still. The maximum point is 2. So maximum value is 2. Okay, when x equals pi, because that end point is 2 pi. So when x equals pi, the function gx absolute value of cosine x minus 1 has a maximum value of 2. So answer is E. Pi is the answer. Okay, to solve all these problems, this is a very good review about any functions you already learned in pre-calculus. Number 10 is about trigonometry function. So you basically understand sine graph looks like this, right? 0 to 2 pi. It is y equals sine x graph. Maximum is 1, minimum is negative 1. What about cosine function graph? We just draw, right? Start from maximum point, the end to maximum point. Maximum is 1, minimum is negative 1, and then period is 2 pi as well. What is a tangent x graph? Tangent x graph, something like this, right? This is one period of tangent graph, 0 to pi. At pi over 2, tangent x doesn't exist. Okay? So you remember basic sine, cosine, tangent function graph like this. Okay, next time I keep solving from number 11. So during summer, okay, you don't have to use many time, but just watch my video every single time. Whenever I post the video, keep watching the video and then keep remind yourself, okay, every single part of the function, because you need this knowledge for next year for the AP Calculus, AP and BC. Okay, thank you so much for watching my video. Click subscribe and like and turn the notification. Thank you again. Bye-bye.